Example 2, we'll work with rotation of an axis for an ellipse. Rotate the axis to eliminate the xy term in the equation 7x squared minus 6 root 3 x times y plus 13y squared minus 16 equals 0. Then we're going to write the equation in standard form and sketch its graph. So first let's identify a, b, and c. So a is 7, b is negative 6 root 3, and c is 13. Therefore, cotangent of 2 theta is a minus c, so 7 minus 13 over b, which is negative 6 over square root of 3. So 7 minus 13 is negative 6 over negative 6 root 3. So therefore, we're looking at cotangent of 2 theta. When does that equal positive 1 over square root of 3? So again, remember this is x over y. And then just to kind of go over a little bit more, remember that's 1 over 2 over root 3 over 2. So when does x equal a half, and when does y equal root 3 over 2? So we're looking at cotangent of 2 theta, and that is when we're looking at pi over 3. And then in order to solve for theta here, oh, it's not cotangent, I apologize, because we already solved for the angle here. So let me go ahead and delete this cotangent. So 2 theta equals pi over 3, and then dividing by 2. So therefore, we are looking at theta is pi over 6. Okay, so that is how much the axis rotates. And so now we're going to do the same thing we did before, substituting our x. So x equals x prime cosine of pi over 6 minus y prime of sine of pi over 6. So then at pi over 6, it's x prime. Pi over 6 is square root of 3 over 2 minus y prime of 1/2. And then so to simplify it, this is root 3 x prime and then minus y prime all over the common denominator of 2. So let's do the y value. Y equals x prime sine of pi over 6 plus y prime of cosine of pi over 6. So this is going to be pi over 6 is 1/2 plus y prime times root 3 over 2. And so therefore this simplifies to x prime plus root 3 y prime all over 2. And that's why I said prime, but I actually wrote squared there. So this is x prime plus square root of 3 y prime over 2. So now we're going to plug it into the original equation all the way up here. And so yes, there is a lot of algebra involved. So this is 7 times x squared. So this is going to be square root of 3 x prime minus y prime over 2 squared. And then minus 6 root 3 times x, which is root 3 x prime minus y prime over 2, times y, which is x prime plus root 3 y prime over 2, and then plus 13 y squared, so that's x prime plus root 3 y prime over 2 squared, and then minus 16 equals 0. So now this is just multiplying everything through, and so this is 7, and then I'm going to square this x here, so it ends up being 3x prime squared minus 2 root 3 x prime y prime plus y prime to the squared all over 2 squared, which is 4. Then let's multiply the next one, negative 6 root 3. And so now with this one, we are going to get square root of 3 times x prime squared minus x prime y prime plus 3x prime y prime. And then if we notice that, that's like terms, so that's going to end up being plus 2x prime y prime. And then the last term, so that is going to be negative root 3 y prime squared all over 4. Then the next one is plus 13 times, and this will be x prime squared plus 2 square root of 3 x prime y prime plus 3 times y prime squared all over 4, and then minus 16 equals 0. So now we need to simplify what we can. So we're going to distribute the 7 inside. So now we have 21x prime squared minus 14 square root of 3x prime y prime plus 7y prime squared, and then minus 6 times 3, that is going to be 18 x prime squared, and then we have negative 12 square root of 3 x prime y prime, and then plus 6 times 3 is 18 y prime squared. And then we have this last one down here. This is going to be plus 13 x prime squared plus 26 square root of 3 x prime y prime plus 13 times 3 is 39y prime squared. And all of this, of course, is all over 4. Then we still have this minus 16. Minus 16 equals 0. So at this point, when you combine like terms, so earlier on, we had stated that when you do the substitution, the x prime, y prime term is going to disappear. So if you ever are at this point and you combine all these terms and you find that you have an x prime, y prime left, then you made an error somewhere and you go back and check. So let's combine like terms. We have 21 x prime squared minus 18 x prime squared plus 13 x prime squared. So that all comes to 16 x prime squared. Then we have negative 14 minus 12 plus 26. That all goes away. So notice that the x prime, y prime should disappear, and it did. Then we have the last one, which is the y squared, so 7 plus 18 plus 39. That ends up being plus 64 y prime squared, and both of those are all over 4. And then we still have this minus 16 equals 0. So let's go ahead and simplify. So this becomes 4x prime squared plus 16 y prime squared, and let's go ahead and move the 16 to the other side, equals 16. Then remember, we're trying to get the standard equation for the ellipse, so divide everything by 16. And so we get the standard equation of x prime squared over 4 plus y prime squared over 1 equals 1. So after all of that, here is our equation for our ellipse. And so we know that A is 2, B is 1 here, so to help us graph it out. Now, number 1, we need to rotate the axes, pi over 6. So pi over 6 is closer to the x-axis, so maybe something like this. I'm just doing a general graph here, see if I can get close to what it would be like. So this is our x prime. We rotated the x-axis and the y-axis. And so along the x-axis, that is 2. So somewhere here and somewhere about here, and then 1 for the y-axis. And so here's our ellipse centered at 0, 0. And so our vertices on the x prime, y prime is at plus or minus 2, 0, right? It's on the x there. And so I hope this helps you out. So you're supposed to graph it, and then also we found the standard equation. So you want to try one out on your own. Rotate the axes to eliminate the xy term in the equation. 12x squared plus 16 root 3 x times y plus 28y squared minus 36 equals 0. So we want to write the equation in standard form and sketch its graph. So try this out. This one is a little bit tough. You are going to get a negative cotangent of 2 theta, so you need to find where that is, and then try this out. See if you can do it. All right, so if you try this out, you would find that you would have gotten a negative 1 over square root of 3. Now remember, it's cotangent of 2 theta equals negative a half over a square root of root 3 over 2. So that's when x is negative a half and y is root 3 over 2. And so when does that happen? And that happens at 2 pi over 3. And then to solve for theta, it is just pi over 3, right? You divide by 2 and it cancels out. So number 1, you have to get that correct, and then you plug everything in. And so at the end, you would have gotten x prime squared over 1 plus y prime squared over 9 equals 1. So because the a value, or the largest value, is over here underneath the y squared, then you know that the vertices are along the y-axis. And so notice that the vertice is at 0 plus or minus 3 on our rotated y-axis.